get the second derivative, right? Now, let's apply this second derivative, some rules, and study the some polynomials, especially the maximum and minimum definition of polynomials. Let me just go let's clear this one. All right, and also I'm gonna get this Desmos. Here is the graph. Let me just put this graph on the screen. Well, you see that graph here, right? Is a polynomial. Is that one here, third-degree polynomial, right? Okay. Take a look at this different point. That point and this one are the roots of the solution when fx is equal to 0. This is fx equals 0. So we have the roots for this polynomial. In that case, we have this and the one here. And now notice there's 2 points. That point here is the one, and that point also is one here. Okay. So here x is 0, right? And here x is minus 1.33. Of course, that is the value of y, the second one. And if you check the value, here y is 0, and then y is 0.18, and then y here is 0 again. That means it's a maximum, because from 0 up to then down. We can get closest. I mean, using the analysis, this graphing calculator, you can tell that one is a maximum. But now we're going to use this definition of the high order derivative, like a second derivative, in order to prove that one is a maximum, actually. And that has also happened with this one. Here is 0, then go down minus 1, then go out again 5. So that is, you see here is just decreasing, and then it start increasing again. Okay, and so that behavior of the function here behaves like decreasing that, then increasing. That's because that's a minimum. Okay, that's what we already know by intuition or by the analysis, by doing the analysis of the graph. But here, how do we do this using calculus? Okay, and the 3 points are, like I said, are from the function. You know how to get it, right? This is just to get the principle how to get this one. If you know, use factorization and get it, okay? And this, you may use one like long division or something like that, just to get this, approach, or use the PQ approach. Or go back, just check what we did, and just to get the root for polynomials degree, the third degree. Well, we want to concentrate or focus on this point now, the minimum and the maximum point. Let's take the first derivative of this function. What is the first derivative of the function? 3x plus 4. Well, that is x squared, right? 3x squared plus 4x, right? Okay, so that's the first derivative. So what happened? The first derivative is the slope. So you go to that point, in this point, what is the value of the slope? Well, it's a horizontal line. It's the tangent is horizontal. That means that slope should be 0. So when the slope is 0, we can have the value right there. So we can know the value, and then we can just get the value x that makes this function or the first derivative equals 0. And then how do we do this? Okay, you get x out there, greatest common factor. You got 3x plus 4. So you got 2 solutions. One solution is x equals 0, right? Second solution, x or 3. Well, by the way, is what do we have here, right? Here x is 0, and here is 1.33. Is it? That's exactly this one here. You see? Okay, so that works with the calculus part. Right? Now, here becomes the rule. The second derivative evaluated to the critical value x, like this one, 0, is that as negative, it's a maximum, is that as the function is second derivative is positive, it's a minimum. And let's check this value. The second, what is the second derivative actually? This one. Well, from the first one, you got 6x plus 4, right? Second derivative. And then what do? We take the value 0, and we do the evaluation using 0, and 0 is 4. 4 is greater than 0, so it's what? It's a minimum, right? So here is a minimum. X is 0. So when x is equal to 4 minus 4/3 is 6 minus 4/3 plus 4, what is plus 4, which is equal to minus 8, right? Minus 8 plus 4 is minus 4. So negative. And then it's negative, does mean it's a maximum, right? So according to the rule, that is what happened. Okay, that's the way we do the analysis of maximum and minimum. In some cases, or later, we're going to study what does that mean by absolute values, absolute minimum, absolute maximum, local minimum, local maximum. Happens some function, you may have two different, for example, maybe something like this. We give you two different maximum, and then you may have an absolute maximum and local maximum, right? And other functions, you may have only one, but it's just a maximum, but it's not an absolute maximum because we cannot declare like an absolute maximum, something like that, right? You remember that particular polynomial, and that one is a maximum, but it's not really an absolute maximum because we have not enough information to close between 2 points, like here or here. Okay, that's very important in the definitions. All right. Other than that, you can use the intuition. Say, okay, the function is increasing that way, and then decreasing, then start increasing again. And that is because the leading coefficient, right, is telling you that part. And in some cases, the first two coefficients tell you what is going on here, especially the first one. You see, that one is negative. You want to see that reverse the function. It's going to be the other way. It's just decreasing first, then increasing after. All right. Let's see what do we have for today. And I have, what is mine? Oh, here we go. Now, we got some, what is my exercises? Let's see if we have my, here we go. Is that the one? Okay, 20 questions. This is the one. Okay, the assignment for today is this one here. Let me get the right function, the right precalculus function here. 3, 4 is a fourth. Okay. No, it's not. Okay, that's a week 6. Almost, we finished the week 6. We're going to start 7. We got like 5 more classes, so almost done. We're almost done. And 0, 5, 13, I guess, is the way. Minimum, maximum. Okay. Oh. You have 3 attempts in this one. Okay, let's check the code and see if that one is active. It's good. 023177. Mm. Mhm. Mhm.